All right, that's not the first slide. Okay, just making sure. Okay, so as Mike said, I'm going to spend a few minutes talking a little bit about the history of the previous workshops and kind of give you a quick sense of how we got to where we are, and also primarily discussing the development of the TVF roadmap, okay? And I'm going to talk a little bit about why we're doing this and who's involved. And it's also kind of a pitch to try and get some of you interested enough that you might choose to participate in this activity as well. So what's the motivation for this roadmap? It's basically a communication exercise. The roadmap is not about developing technologies. The roadmap is about understanding what this community is about, what this new vision is about, and how we're going to get there. And as Mark alluded to earlier, or Mark Moore alluded to earlier, this isn't just about the vehicles, this isn't just about the technology. There is a whole spectrum of things that need to be accomplished and happen concurrently for this to succeed. And so I'm going to try and just discuss that a little bit and give you a sense of that. So, you know, how did this happen, okay, or why are we here? Well, about 4 years ago, the first workshop was held, and a group of people got together, primarily people interested in this field, technologists, but also business entrepreneurs and people that were you know, dedicated to seeing new transportation systems evolve, and they had a vision for something that could be better, okay? And they believed that there was an opportunity to create a transportation system that had greater flexibility, improved convenience, you know, more environmentally friendly, and could enhance air transportation services, okay? And so the result of that first workshop was basically, yeah, there's something there, we think we should pursue this, but in order to do that, in order to make this happen, in order to make anything happen, you really have to have a compelling story that you can articulate to people so that they understand what it is that you're trying to do and why should they participate, why should they even be interested. And so in order to develop this story, we figured that, you know, well, you've got to be able to explain the key elements. And the key elements aren't just technology, but it's really being able to tell people, okay, what are the operational concepts? You know, how are you going to do this? What are the technology barriers that you have to deal with? And really, what are the business opportunities, as well as, you know, you got to be able to manage stakeholder expectations, okay? So it was agreed upon that a transformative vertical flight roadmap could be a valuable tool to tell this story. So, you know, this is just you know, just trying to say, okay, what do you need to tell a good story? Okay, any story. You have to be able to say, okay, you know, what is it, how is it, who is it, and why, you know, what are the whys? And the what is really, what is the capability being created? The how is, what is the technology? What are the things that you have to create to get there? The who are the stakeholders, the regulators, who's going to be impacted by this? And the why is basically, in most cases, it's business opportunities. Who's going to make money on this? You know, why would anybody, you know, want to do this and see this happen? So those are kind of the elements of the roadmap, and I'm not going to spend a lot of time on that, but you can be happy to discuss it with you at length, and we've got lots of information available on that motivation. So what's driving this? Okay, well, there's several key factors that have emerged over the last few years that are helping make this more feasible, helping generate interest. And here's just a few of them, but the obvious ones, and that is that there's technologies emerging that didn't exist just a few years ago. Some of the key ones are the autonomous systems, electric propulsion, which you've heard about a lot the last couple of days, and I expect to hear a lot more. And not just the electric propulsion, but how do you integrate that into an airframe effectively? And also more and more effective energy storage systems that you need to enable these electric propulsion systems. But at the same time, we also have societal demands that are emerging. Okay, people want more affordable, on-demand air mobility, or else Uber wouldn't be doing all the stuff they're doing. Okay, and people are expecting or hoping for relief from some of the air and ground congestion that they're experiencing. You know, this evolution toward gridlock. There's also business opportunities that are being recognized for the urban and regional air transportation service, Uber, one of them, but also there's business opportunities for the manufacturing of the new vehicle types and systems. And you've also heard a lot about some of the concepts that are being pursued right now. And then finally, there's another important factor, and that is the possible relaxation of some of the operational constraints, okay? So, one of the things that these technologies enable is the use of a lot of existing infrastructure that is currently underutilized. There's a lot of heliports, there's a lot of small airports, even some regional, major regional airports that really are not being fully utilized, and these technologies could help take advantage of that. And also there is an evolution, particularly with NextGen and other UTM and other air traffic management services and systems that are being developed that have the potential of making some of these new innovative concepts more viable from a regulatory and transportation management system perspective. Okay, quickly, I'm not going to read through all of this, but this is the fifth of the TVF workshops, the fifth that has occurred in 4 years. The first one, as I mentioned, was basically just, okay, people getting together to try to see if there's a consensus, if there's anything there that's worth pursuing, so that it was agreed to hold follow-on workshops. The second workshop, basically brought people together to start discussing the available and emerging technologies, as well as some of the what, how, who, and why that I just discussed, and the recognition that it might be a good idea to start developing a roadmap that could articulate, what this vision was. So the third workshop was dedicated to trying to sort of sketch out what the roadmap might look like. We had about 150 people that attended that workshop, and they all just started putting stickies on the walls. Some of you may have been there, but the idea was to just try and collect ideas of what are the things that need to happen and what was the time frame and in what areas. And so we basically had it divided up into concepts, technology, market, and regulatory issues and activities. And we put all this stuff up on the wall, and we developed a, kind of a notional roadmap, which was not vetted in any way. It was just the opinion of a bunch of people that were in the room, but it served as a good starting point. So we said, okay, this kind of gives us, sort of scopes out the problem. We also recognized that if we just meet annually, that's not going to be fast enough to really pursue this at any reasonable rate. And so, the consensus evolved that we would create working groups that could meet on a more regular basis, and those working groups have been established. We have established 4 working groups that you're going to hear about their progress that they've made in the last 6 months. I'll introduce them in just a moment. But in order to organize the roadmap, we broke it into 4 mission-related areas, and we're going to walk through those in just a minute. And then the meet using telepresence tools that enable them to get together on a routine basis, even though that they're geographically distributed across the country. And excuse me. And in the 4th workshop, we kind of kicked off that process. We had some practice sessions and established the working groups and recruited the leaders for those working groups that are going to be speaking in a moment. There's some website URLs at the bottom that have a lot of additional information if you're interested in looking at this more. The NARI website has web pages that'll take you to, each working group has its own web page, and you can see in more detail what their progress has been. Okay, so what's the status? The workshop, the 3rd workshop, started, as I said, collected those activities. The 4th workshop organized them into these 4 core elements. The recreational vehicle, these are basically mission-oriented. Commercial intracity, which is kind of the Uber Elevate type mission. Commercial intercity, which would be longer range, city to city. And then public services, which would address issues related to medical, fire, law enforcement, military, that sort of thing. The working groups have been established. They're working at a reasonably quick cadence. They are developing their information and they're posting it on the website. And as I mentioned, it's repeated there where you can go see that. And finally, what are they trying to do? So this is just a quick summary of what the working group's objectives are. So as I mentioned, the first notional roadmap was just a bunch of unvetted activities that were a bunch of people's opinions. Well, for this story to be meaningful, it's got to be a community consensus. Okay, it can't just be one person's opinion. You have to have these ideas floated and discussed, debated, and then once they've come to a consensus that they're meaningful and reasonable, then they go on the roadmap and they're posted. And it's not just a little cryptic title, but the working groups are also developing a little more detailed description about what these titles mean and also identifying some of the dependencies. So what has to occur before this activity can take place, and what does this activity help enable? And one of the problems when you just have sort of this a bunch of ideas being stuck on the board, you know, we ended up with some activities that were saying, okay, well, we're going to have this vehicle flying in such and such a date, but the regulatory framework for that particular vehicle type might not appear until a couple of years later. So we have to get all these activities reconciled to be consistent with each other, and the only way to do that is get a bunch of knowledgeable people together discussing it, debating it, coming up with opinions about the realism of these activities. And so the idea is not for these roadmaps to be a finished product today. It's something that has to evolve over time. And one of the reasons that I'm kind of pitching this to all of you right now is for this thing to be successful, we have to get more people involved. We have about 42 people involved right now, but if it's just a small group of people, it's going to be just the opinion of those few people, and the roadmap will not have any credibility. The other reason for I'm encouraging you to think about participating in this is that, okay, something's going to be produced, it's going to go forward. If you want to participate, if you want to have a say in it, here's your opportunity. Okay, you participate in these groups, and it's not a lifetime activity. You can join a working group, see what's going on, find out where you think your input would be valuable, make those inputs, and then you can move on and let somebody else come in. So that's kind of where we're going with that. There's one other sort of important point that I want to make. I work for NASA, but this roadmap development is not a NASA activity per se. NASA is providing, contributing support to it. So there's several, NASA employees that are participating in the roadmap development. But it is not NASA's intent to dictate to the community what they think the vision of TVF is. This has to come from all of you, and not just the technologists, but businesses, regulators, everyone. So with that, I'm going to introduce the 4 working group leads, okay, who are going to come up and give you a quick or a brief overview of kind of what their groups have been up to. It's not going to be comprehensive by any means, but the idea is to just kind of give you a taste of what they've been up to. So the first speaker following me is going to be Tony Linn, okay, and I'm going to read his bio here, so if you'll bear with me for a moment, and I'm going to go through all 4 of them, all 4 of the bios, and then hopefully that'll make this run a little bit smoother and save some time. So, as an engineering consultant, Dr. Anthony Linn has several decades of experience in light aircraft propulsion, including gas turbines and aircraft certification. He has conducted research in unsteady aerodynamics, turbulence, and aircraft certification with a teaching emphasis in turbomachinery, aircraft dynamics and control, and fluids. While at Worcester Polytechnic Institute, he conducted research for FAA production certification of the NASA personal air vehicle intended to be manufactured using commercial off-the-shelf automotive components to meet cost constraints. He also conducted research in dynamic stall, turbulence, boundary layer instability, and turbulent bursts through direct numerical simulation. He has served as a consultant to a variety of industries, including glass and ceramics, packaging, consumer product manufacturing, water treatment, and light aircraft manufacturing. His design contributions include control systems architecture and automated manufacturing systems, analysis of light rotorcraft dynamics and structures, and plant startup for large automated facilities. Dr. Linn has commercial and flight instructor pilot certificates, is an active member of the Experimental Aircraft Association and the Aircraft Owners and Pilots Association, and conducts advanced flight training. He chairs the AIAA General Aviation Technical Committee and former chair of the ASME Worcester section and the AIAA New England section. So that is Tony's bio and background. For the second working group, the commercial intercity, and I should have mentioned Tony, obviously you can see on the chart there, is leading the private recreational vehicle working group. Dr. Anubhav Datta is an associate professor of aerospace engineering at the University of Maryland at College Park. Prior to joining Maryland, he was at the U.S. Army Aero Flight Dynamics Directorate at NASA Ames Research Center for 9 years, 2007 to 2016. His research includes electric aviation, computational aeromechanics, and high-speed tilt rotors. Over the years, his work has received the Francois Bagnoud and Alfred Gessau and Grover E. Bell Awards from AHS International for significant contributions to the advancement of rotorcraft technology, including 5 Best Paper Awards in Dynamics. He currently serves as the chair of the AIAA Structures Dynamics Conference Committee, a member of the AHS Dynamics Committee, and leads the Transformative Vertical Flight Roadmap Development Commercial Intercity Working Group. He is an AIAA Associate Fellow and Associate Editor of the Journal of American Helicopter Society. And that is Dr. Datta. The lead of the third working group for commercial intercity is Saren Weber, but she was unable to make it, and Yolanka Wulff has graciously agreed to step in for her, and she will be presenting the information on the progress of that group. And Yolanka is the Director of Communications and Public Affairs at Ampaire. She is a business attorney and consultant with over 2 decades of experience in the successful development, implementation, and management of mission-driven programs. Prior to joining Ampaire, Yolanka was a sustainable aviation consultant for 8 years, working with industry, government, academia, and nonprofits on policy, standards, and regulations, industry development, marketing challenges, communication, and media relations. She currently serves as Executive Director of CAFE Foundation, where she organizes the annual Electric Aircraft Symposium. And finally, leading the fourth group is Johnny Du. Johnny has over 30 years of experience in developing, managing, and marketing aviation products, from high-performance piston aircraft and business jets to new generation aircraft engines. He is currently the president of International Vehicle Research Incorporated, focusing on innovative manned and unmanned flight vehicles, technology and product development while supporting global rescue and disaster relief initiatives. He was previously the Executive VP of Marketing and Business Development and Advanced Technology at Continental Motors Group, where he also managed the Engineering and Product Integrity Department for this leading general aviation engine company. Prior to Continental Motors, he was the VP of D-Jet at Diamond Aircraft in Canada, where he built an integrated program team, established the development, certification, and production plan, and led the development of the all-composite single-engine personal jet. Johnny has a bachelor's degree in mechanical engineering and a master's degree in aerospace engineering. He is also a co-author of the book WIG Aircraft and Echanoplane, Grand Effect Aircraft Technology. And for those of you that don't know what that is, because I didn't before I looked it up, that's basically giant marine hovercraft transports. So with that, I'll turn it over to Tony.
So working group number one, first of all, I want to say that very little, if any, of this, what I'm about to tell you is vetted. Largely because the group has been very, well, although the group is relatively large, the active participants are only a couple of us. In fact, also, the other thing is I've changed the group name to private and personal use rather than necessarily recreation. And do we show the second slide at the same time, or what's going on here? Okay. So what we've started with is an overall working group outline. And the outline is actually a very large Excel spreadsheet that, and these are the left-hand column primary areas, which is acceptance, technology, which Dr. Datta will delve in more deeply than I will, and then the next two categories are, certification and infrastructure. And these categories all sort of extend to the right on this worksheet. These are sort of, I'm giving you the major bullet points in the left-hand column. And as we go to the right on our spreadsheet, we're looking at different timelines. Timeline to the right and basically topics top to bottom. So what I want to concentrate on here today is this beginning from the beginning really, and that is we're going to focus on a few things. First of all is acceptance. If we can build things, but if nobody wants them, they're really of no use. The next thing is the time savings and personal convenience, which is one of the bullets within acceptance. Certification in that area, it's going to look first at training because that's something that I'm probably more familiar with. And it's too early, really, to start looking at the actual certification by, say, the FAA or other organizations. And the last is infrastructure. Look quickly at infrastructure, both in terms of, say, the urban vertiport and the suburban air park, and how they may contribute to or not contribute to this personal or private vehicles. So we're building something, or we think we're going to build something, and the question is, will anyone buy it? And it comes down to a question of utility. We buy things which we can utilize, and so we're looking at transportation, and the question is, how useful is a particular mode of transportation? The thing we look at here is the primary factor of usage is going to be its utility. And we all have, almost all of us have cars today. We can't get a job without a car. We can't get anywhere around town without a car. If you live in suburbia, you need a car. And so we find that we get a great deal of utility out of the automobile because we use it just about daily. And commuting, shopping, short distance travel, all of these things are things we do just about every day. On the other hand, if we look at aircraft, and by this I'm referring primarily to general aviation aircraft, which are going to be self-piloted or even professionally operated. And once again, as I said, I'm the chair of the General Aviation TC, so this is a focus of ours in this area. I'm also an aircraft owner, in fact, so we also look at that. We find that we don't have as frequent a need for aircraft. Aircraft tend to lend themselves better to use for long distances, high speeds. We can't get door to door. And so at least the aircraft we have in the general aviation fleet now fit this category. And the next thing is, I call this the question of congestion. I'm going to tell you a little story in that my wife and I moved about 30 miles outside of Boston to suburbia about 10 or 11 years ago, and by luck she ended up with a 35-mile commute, and I ended up with a job in town, and so I don't hear the end of that very often, so you can imagine. So and on a Friday afternoon she'll call me up and say, well, I'm heading home with 5,000 of my closest friends on the Mass Turnpike. Well, I decided to poke around a little bit before I came today, and I discovered that, wrong slide here. let's first talk about the cost of the congestion here, and that is, and this was data from Texas A&M, their mobility scorecard, and this refers primarily, well, to the entire country. One of the things is time. In the United States, we've got almost 7 billion hours of travel time we waste every year. And an average rate of 42 hours per person per year. And if you're in a populated area, it's quite a bit more. It's about 1.5 times that. And then the question of energy, fuel, much higher. Okay, 33 billion gallons of fuel every year. So these are areas where we're looking to try and eliminate. And I think this is not new. This is clearly things we've talked about earlier. Uber talks to about this as well. Now to the next, increased infrastructure costs and maintenance. Yes. We build roads in order to meet the utilization requirements from 6 o'clock in the morning to 9 o'clock in the morning, and again in the afternoon when everybody goes home. Other than that, they're terribly underutilized. So now, the commute. And this is where I should have started my story here, okay? So instead of heading home with 5,000 of your closest friends, if you look at the Boston area, it's about 780,000 of your closest friends who are in play in the morning and in the afternoon, okay? And this next link here, I'd like to quickly, if we could play that now. Is that all loaded? Here we go. Let's see if this works. I was fascinated by this, but get it to work. Yes, maybe. Here we go. Scroll that down. You're going to keep going. All right. So now just select state, Massachusetts, and select Middlesex County. All right. So this is where everybody goes every day. Down further. There you go. I thought this was fascinating. Okay, this is where everybody goes every day. Okay, this is only one county out of the western, or rather central Massachusetts, or I should say really eastern Massachusetts. The yellow bunch, they all go downtown Boston. There's some incredible commutes in there, okay? And the thing that impressed me was that we really didn't have a single major direction that everybody wanted to go in. Everybody just about goes in every direction here. So, all right, let's go back to our slides here. I'll show you where that link is later, okay? And actually, you can select that for anywhere in the country. Okay. Let's see. Keep going here. All right, we'll catch up to this in a second. All right. So I think the largest opportunity for aircraft utility is going to be in commuting. Okay. I think that's really the important thing to consider here is that we have, let me go backwards here again. All right, I thought there was another line there. All right, so our largest opportunity for aircraft utility would be in personal commuting. I want to talk a little bit about training here because we often talk about the effort put into flight training, and I think we need to put that into perspective. And I want you to look at some of these numbers right here. And I suppose, what do you guys think that these numbers are for? If I told you those were requirements for training, those look like flight training numbers to you? Do they? Okay. I'm going to kick another one down here. 50 hours of instruction. All right. Turns out, actually, those are driver's license requirements for various states. And I think that realistically, we don't remember when we learned to drive. Probably it was paid for by some sort of driver education from our high school or something like that, okay? All right. If we compare that, and I'll say, I did cherry pick these a bit, and most of them are probably 15 hours, but there were these few here that were outliers that were every bit as much as what it takes to do the private pilot flight training for the FAA. The difference here really is the cost, okay? We all have cars, so there's no problem finding some way training platform for our automotive training. it's the cost and the availability of pilot training. You know, you don't have an airport in every corner. There are not even a lot of instructors these days that are willing to do much training anymore. So this, once again, is an obstacle that reduces sort of that utility of the utility we have of using aircraft for commuting. Now, once again, we'll look at the automobile, high utility, we use it every day, low cost. The airplane now, low utility, used in special case or conditions, again, high cost. This cost is related to the level of usage. And the cost is also related to the degree or the volume of manufacture. Look at the cost of a light aircraft, and I haven't vetted these numbers. This is the best I could find in research, but for the assembly time for, say, one of the Cirrus models is about 2,000 hours. And if we look at the assembly time for Cessna 172, they've brought that model back. I think it's probably less than 2,000 hours right now, but it's still it's over 1,000 hours. Anybody have any idea what the automotive assembly averages are? Pardon? More than that. They're about, they vary by manufacturer, about 35 hours. This is an industry, this is a model average for Hyundai, okay, 33 hours, 32 and a half hours, so to speak. Toyota's of this list is the best, and of course, I'll have to say to you that these vary actually even within the manufacturer's line. Fiat Chrysler doesn't report this any longer because they've gone private, but some of their simpler vehicles, like the Jeep Wrangler, was only like 11 and a half hours. So, but you can see we have almost an order of magnitude and a half in the man or person hours that go into making these vehicles. And so this is one of our largest contributions to what the cost is. And the cost of light aircraft continue. They don't really depreciate. Okay, operating cost energy. And these are some very, very broad comparisons. But I thought I'd start with, say, a modern car like the Tesla Model X. And just the Google research I did looked at as though it was about 500 watt hours per mile at a speed of about 60 miles, at highway speeds, pretty much. So this works out about 30 kilowatts or about 40 horsepower. And if we look at this as a transportation device, where it's a curb weight or an empty weight of 5,300 pounds, pretty heavy machine. Another vehicle, for instance, the C-Max Hybrid, which leaves my house and goes to Boston every day, comparable in a cost of actually a little bit cheaper to run than the Tesla X, at least in the fuel, petroleum cost and cost of electricity retail in Massachusetts. Favors the C-Max a little bit. So this gets you from, either one of these will get you from my house in Westboro to Boston to a parking garage on Stewart Street in downtown Boston in about 45 minutes on a good day. On a bad day, hour and a half. Really bad day, 2.5 hours. If we go over here and look at GA aircraft, which can't do this because it can't land there. Oops, sorry, I dropped you all. Just a second here, get hooked up again. And we said, all right, well, let's say what would happen if we could actually take this GA aircraft from my house to the parking garage in Boston. It would do it in about 10 minutes. But even in that 10-minute period of time, the energy consumed by that aircraft would be still about twice that of the C-Max in terms of the amount of fuel. But we have more aircraft, or we have more vehicle across the board here than we really need. The objective is to get one person from home to the office. So we really don't need 4 passenger seats. 2, maybe even 1 would be fine. So I guess what gets to be the point is, if we had a commuter flight vehicle that was of minimum size, and I think that, and I wrote this before I came to this, I can see now that there are vehicles that are of this size, or people are working on them already. And I think this is the direction for the personal commuting vehicle is probably going to end up in an area of this space like this. That's going to be the largest volume, has the most utility of anything that we would want to have going forward as a personal vehicle. Let's see. Environmental benefits. That was one of the other things on our list here we were looking at. And so we've pretty much maxed out the road systems in a built-up area like Greater Boston area. About 10 or 12 years ago, they finished the Big Dig, which took the Central Artery, which was this giant steel elevated expressway that went through along the waterfront, and they took it all down and they dug tunnels and they put it underground. They're never going to widen that, clearly. And the original price tag was $200 million. In the end, it was about 15 or 16 billion with a B. I mean, it was, and honestly, today the traffic isn't any better than it was then. Okay, it didn't get any better. It's still the same. And so the point is, we have to go somewhere else. All right. Parity in energy use, and I say parity because looking at those vehicles I showed you earlier, the Tesla, the C-Max, the light aircraft, and some concept vehicle that might exist. We can't look at apples and apples. We cannot take a car and say we're going to take a 5,000-pound automobile and put fans on it and fly it around. And I don't think we need to. The physics of flight are going to tell us that if we do that, we're going to end up with a higher energy usage than if we simply built a vehicle that was enough to do the mission of getting one person or maybe two people from home to the office and then back at the end of the day. Reduction in traffic noise. I think that this is going to depend, and I put question marks behind this because noise is probably going to be one of the largest, most difficult problems to solve, and I think that's been borne out by a number of conversations and probably some papers here as well. I didn't attend the conference. I'm here only for the workshop. So, and let's talk a little bit about infrastructure. What we're looking at here is an air park, and air parks are great if you own an airplane and you want to fly it in your backyard. And certainly the air park could serve both fixed wing or VTOL or even some sort of specialized commuter vehicle that would that I'm kind of describing here. But the problem with them is they require a lot of land. This runway here, I believe, is 3,000 feet long, and by the time you put an overrun on each end, you're near the 1,000 feet. And if you have as much space on the sides as you're supposed to, plus taxiways and everything else, you're going to eat up 30 to 40 acres right away before you build anything else. And that really puts the price tag up for finished building lot costs and things of that sort. And the other thing you have to consider also is that aircraft are larger. If you're going to have a garage for your airplane, it's probably going to be the size of a 4-car garage for a car. That's fine if you really want an airplane. But if you're looking for a vehicle that's going to take you from the home to the office and back, you probably don't have the option of living at an air park. And because there's so much ancillary or additional land required, it's difficult to get air parks to service a lot of users. This happens to be Lake Norman, South Carolina, which is about 30 miles northwest of Charlotte. Okay? Vertiports. This is a Google Earth picture of the garage that the C-Max goes to every day. And that's the roof, and the roof is dimensions kind of up to the left there, about 170 feet, and over to the right about 270 feet. Notwithstanding, the surveys of approaches and everything else to whether you could land on it or not, I mean, there's certainly enough room to have helicopter pads in there, much less some sort of landing arrangement or some sort of landing structure that will allow you to receive and or launch aircraft from the roof of this existing structure. Yep, okay, so anyway, open parking lots. The other thing is, can we get to open parking lots in suburban settings? When we looked at that little video there I showed you earlier, I mean, everybody goes everywhere. So they're not always going downtown. We're actually going to places like from suburban locations to other suburban locations, which would be certainly served by open parking lots. Anyway, this is the Motormart garage, 1,000 parking spaces. I think we should be able to actually use a facility like this part-way can load it from the street from the bottom. And if we have vehicles that land on the roof and can configure themselves to be automobile size after they've landed, and they're mobile enough, we should be able to park them in the garage as well. They should be able to share the spaces. So these are the things I say here in the future, okay? You know, not a flying car. Doesn't have to go highway speeds. It just has to be able to get out of the way after it lands and go to a parking space. One of the things that I feel that this will offer us is large production volumes, because everybody needs to commute to work, or most of us do at least. And I think that this is therefore provides the utility we really need. Quickly to the group members. These are the members of the group. And let's see, I could use help from anybody who would like to join this group. Dr. Marlena Pavel and let's see, Lieutenant Colonel Nathan Diller are the two people that have been most helpful here with this. All right, thank you.
So the Transformative Vertical Flight Working Group used to be very unstructured and an organic, sort of nebulous meeting. A lot of energy, enthusiasm, entrepreneurial spirit, but we wanted something concrete to come out of it. By we, I mean NASA and the AHS. And so we wanted to lend some kind of structure to it. And that's the genesis of the working group. As soon as you say working group, if you're serious, people will ask you, who are you working for? Are you working for Uber? NASA says, no, we're not working for NASA. Are we working for AHS out of our own intellectual curiosity? So this was the first time such a thing has been attempted, as Mike described. So let's go to the next one. Oh. So the first order of business was to define the role of the working group. So we wanted to identify the technical barriers, which is easy to do, and it's easy to run through telecom. If for nothing, everybody wants to share their problems and complaints. But then we wanted to quantify them into specific actionable problems. And that requires subject matter experts. And they either don't have time or they don't want to talk. But they are the people whom you like to interact with. And then, based on those problems, you want to recommend key activities to overcome them. And there's a reason this sort of thing, if you're serious, is typically done at the National Academy level, because you know, people have different kinds of recommendations depending on which area they're coming from, technological or operational or business regulatory. And there could be conflicts of interest. But so we had to define a list of tasks. So this is what we wanted to accomplish, and we did accomplish. So we had to create an elementary, at least a baseline mission. Can't hear me? Well, you can read. So we had to create a baseline mission, and there are several missions. NASA has published this mission. Mike Duffy in Boeing, he has published different kinds of mission focused on cost. Uber has outlines of their mission. And we went back and forth a little bit with Mark Moore to refine some of that. So all of those you will find in the report that will come to the next slide. And then we had to recruit subject matter experts who would evaluate the status of technology in the context of that mission. And in the first year, we started by focusing on electric power. And that's, you know, electric power and deep learning are the two foundational technologies behind this. You know, if you can fly for only 5 minutes or 10 minutes and crash, it doesn't matter whether you crash quietly or with a lot of noise. So that was the driving main emphasis. And then we assigned them to document the state of the art. So we did it by appointment and by committee. And so we wanted them to document the state of the art. And then also survey the R&D horizon with credible and, you know, what I called credible and conservative future outlook. We're not making computer chips here. So if one thing falls and people are killed, that can be the end of the industry that we are dreaming to create in the future. So all of that, the final product is a report. It's a short 60-page report, and I'm not going to go through it. I meant to, but interest of time, I'll skip it. If you're interested, look through it. I'll show you the contents, but before that, this is the committee. It's a healthy breakup between industry, laboratories, and academia. A lot of participation from Europe, so it was difficult initially to synchronize the time. But these are the members who actually contributed and helped me compile the report. I mean, a lot of people would like to listen to what you're doing, but these are the actual people who worked. Here's the top-level content. So we start with surveying all the 56 eVTOLs that are that you can find today. Thanks to Mike Hirschberg, he did an excellent job. There's not enough data to create scientifically meaningful plots, but at least you should be familiar with all the 56 concepts. A lot of them are silly, but many are very serious and important. Then I talked about the mission, so then there's a description of the mission, and then we go into technology, and these are the specific areas. And keep in mind, it's legitimate for the companies to look 3 years, 6 years, but as a working group, we are also looking 10 years, 20 years, because the target audience or readership of this document is not only innovators, entrepreneurs, but also researchers and government decision makers who are trying to lay out a plan for 10, 20 years into the future and more. And I think Dave Peters brought up this important issue of cyber physical security, so we have a separate section dedicated on that. The person I recruited actually is also working on the recent Amtrak accident, which was because of a sensor compromise. They have a more technical term for it, I don't remember now. And then one of our commercial pilots in the group, so he wrote up the piece on pilot certification. So I'm not going to go over any of these details. These are not covered, not because they're not important, but it takes time to recruit key people who can contribute facts and data. And so these are things left for the future. And some of these things are lower priority because NASA is already working very actively on them. So airspace integration, really, there is no need for you to read what we have to say for 2-3 pages, I think. All right, that's it.
Yes? Okay. Well, unlike Francisco, who had to quickly come up with a slide deck, I have to stand up here and give somebody else's presentation, and I'm not sure which is more challenging, but I will do my best. So our working group is the commercial intercity, longer range, suburban and regional transit, and package distribution. And you know, in looking at this mission, we realize that though this project is being hosted by AHS, and that this is a mission that blends into more than just VTOL. And so there's not a hard line there, and we wanted to make sure that we looked at this from a mission approach and not a hard line, just VTOL approach. And I think it will end up with a better result that way, having looked at it from the mission approach. So you've seen from Tony already all the categories, and he's described to you the spreadsheet. We're all working from that same spreadsheet, so the different categories and the different time frames. What I'm going to do in this is highlight some of the areas that we have started to look at. As described, we're meeting by web. We've had 6 recorded meetings since October. We've been trying to meet every other week except for over the holidays. And we're taking an approach of looking at those topics that are most meaningful or most urgent to our particular mission, and having different people do one-page informationals. They're often a couple of pages, I should say, but those documents are on the website. So we've completed 3 of those to date. We have one on acceptance, and that was looking at the general market demand. Marlena did this one. And considering the net environmental benefits, the energy savings, and the mission and business advantage. She looked at a number of reports, particularly focused on Europe, and found some interesting things. For instance, in looking at airlines and how they approach their markets, what the studies have shown is that an airline will be more inclined to increase frequency than they will to increase the size of their aircraft, which actually pushes for an approach that allows for smaller aircraft to fly more frequently. And that was something that was very encouraging to us in looking at the regional market. I think in looking at this business use case, what we're really seeing is that we're looking at a market, the regional market, that has over the past number of years declined significantly. We have pilot shortages, but we have large operating costs, and that's really what's driving the issue in that market. Certainly in this country, we've ended up with very much of a hub and spoke model, and what we are looking at is the opportunity to turn that hub and spoke into a spider web. There are, I know, as Mike knows, has talked about with the study that NASA looked at, there are thousands of airports in this country that are unused or underused that could effectively create that spider web if we could find a cost-effective way to connect them. And electric and hybrid electric is an opportunity to do that. So our first one-pager in the acceptance market study area looked at that, specifically looking at some studies in Europe. We have a one-pager on airframe VTOL and propulsion airframe integration that gives a nice summary of some of the issues that have been addressed so far, and then looking at what do we need to look at, how do we spread this out over the timeline, and you can see there the different categories that this points to and that we will need to do further research on. And finally, integrated flight. We have a one-pager on integrated flight, looking at flight controls and pilot aircraft interfaces. Again, this is some of the same topics that you've already heard about in the other categories. So we're looking at this from our category. We did spend some time looking at and talking about different missions and use cases. So we've looked, we're basically in the 50 to 100 mile range for our trips. So, what does that involve? That can involve smaller city-to-city trips, corporate flights from one corporate center to another corporate center, recreational, think Los Angeles to Las Vegas. These are some of the use cases that come up when you look at this market, and there's a pretty wide range of possible uses for this market. So as we move forward, we're going to be looking at those uses and where electric and perhaps hybrid electric to begin with makes the most sense. Again, these are some of the topics you've seen before. These are the ones that we're particularly looking for, so or looking at and looking to do these one-pagers that help move us down that roadmap and develop that roadmap. So I won't read through them. I'll try to get us back on schedule here. But you can see that these are some of the concepts that particularly relate to our mission. Again, looking at, in terms of infrastructure, because we're not purely VTOL, we can also look at some of the existing infrastructure. We don't have, we have different issues around certification, regulation, and infrastructure as we look at using some existing airports. And I think, I think we have the same situation with noise. Since we are not right in the middle of the urban environment, we don't have quite the same level of noise concerns that the intracity urban air mobility has. But we certainly do have, we're looking at missions that are in the suburban area, so we do need to consider noise. I think the other, finally, the last interesting piece that for our group that we are looking at is how we tie into the other missions, particularly the intercity mission. So for example, if you have a well-developed urban air mobility system that functions well with an Uber ground transportation system, how do you, from a mission perspective and operational perspective, integrate that and expand the usefulness of that system by looking at longer regional transportation? So I will be personally interested to see as we move forward how these working groups continue to integrate what they're doing and make sure that we do build a fully integrated system and we don't end up siloing ourselves as this industry likes to do. Okay, thank you.
Well, I'm Johnny Dew, heads up the group 4, which is the public services. And actually, our area, what we focus on, at least initial effort that we've been doing, is how to use it, what's the demand, what's the opportunity, and so that we're not duplicating a lot of work like done in the group 2 and so on. So we'll try to complement each other's work. As far as the area that we try to cover is the search and rescue, law enforcement, medical transport, emergency humanitarian response, and military operations. On the surface, they seem to be totally unrelated and very different. But when we have some group discussions, it seems like they actually converge into some basic requirements. Is that we need to be able to get in, we need to get people out, or we need to deliver goods or product or service or food and water and medicine. So that leads us to think that we probably can converge to encourage some development of some baseline product or platform that can be of use for more than one area. And this is our team. In June 2017, we have 12 members. And I'm proud to say that we have, oh, okay.
There's a little issue with the microphone, so I'm just putting on a second one.
Okay.
Sorry about this. Technical issue.
All right, I better not walk around them. Microphone to death. Yeah. And you can see that also we have a pretty good coverage, from Department of Transportation, FAA, GAMA, SAE, U.S. Air Force. There is very helpful in terms of the military applications and so on. We also have a university represented here, as well as end user like Globalmatic, for example, as well as some industry potential manufacturers and so on. So that's, I think we have a good broad-based coverage, and I like to echo what Mike says, that we can use more. I mean, we're not far from complete. Not all members can participate. We have conducted 10 online work sessions so far, and not all members can attend every session, but each session we have a specific topic that we try to cover and generate some dialogue and input and debate.
Yeah, so we really do need that extra mic here.
We do have some. The other mic. One more mic. All right, I'll take one more mic. I don't think I can take off, with all this weight. now, through some interesting discussions and possibilities and so on, we like to believe that for this kind of applications, even if we cannot get to 10 to the minus 9 reliability on every system, every element, but we're pretty much convinced at this point that we could develop a platform that is safer than the current means of mission. And with that, if we have a chance to save some lives, I think we should try our best to deploy those platforms. And also, by deploying those platforms in the life-critical situations, we can demonstrate their use and reliability, and the operating learn how to operate, and therefore we can pave the way for mass civilian Uber-type operations and so on. So we set a pretty aggressive goal. That's definitely a stretch goal. Say 2020 initial demonstrator and trial tests, and 2022 started the field deployment. And both stretch goal actually. And we think the initial capability demo units need to be at least carry 1 to 2 person with 25-mile round trip capability. Different than the Uber type, we can land somewhere and charge, and in our mission, most of the time, there's no place to charge. Once you land, you have to be able to come back. But we think in 25-mile range, we can do a lot of missions. If you look at like Houston, Harvey situation, I was right there nearby when it happens, and as I drove in that area, I can see that there's a whole bunch of inbound logistics support, volunteers, and Red Cross. And the convoy goes out to about 10, 15 miles. And therefore, there's no place to land or launch our platform. And therefore, that's why we said, 25-mile round trip, we can probably do a lot of good in most situations. And so just cover some of the topic, search and rescue. You can all kinds of conditions, earthquake, mountain rescue, water, flood. And I think the transformative vertical flight machine are ideal for this. We can be more readily available, launch on the short notice. And law enforcement, the mid picture is the Paris, after the attack. And this is actually a very broad area. Law enforcement application, they run into all kinds of situations. I talked to a police deputy in Mobile City, and I can't believe his description of what kind of job they have. It's just mind-boggling. So the platform needs to be very utility, not a single mission type platform. That's how they look at the UAVs, and that's how they're going to look at this. And medical transport, right now we use Learjets and so on, but sometimes we have a short range requirement. We need to get people to a medical care real quick. Man, if we have more of the small single 1-2 person transport devices, I think we can make a lot of differences. It's we all know time is critical when something happens. And emergency situation, humanitarian response. Couple of examples. You look at the picture. I like that concept. It's a quad rotor, but you can put somebody got hurt in the traffic accident. You put them in there, get you to the hospital real quick. I think that's an ideal application. And the other situation, for example, the picture down below is quite often. Sometimes we call the last mile. It's really not the last mile. Sometimes the last 5 mile or 10 mile. We have the staging area. We get a lot of supply and so on into the disaster area and so on. And we couldn't get into the final destination because there's no roadway, there's no transport capacity to get there. And I think we can make a difference. And of course, military operation. With some discussions, we think the practical application early stage will be resupply. Not necessarily the initial deployment. For example, if a Special Operation Command has a 5-man team out there in the field somewhere, and the mission changes or condition changes, the equipment, facility, stuff that they carry wasn't tailored for the mission anymore, we can quickly have a resupply mission to keep the mission going, change directions and change locations. And also, if somebody get hurt, somebody could get shot or whatever, get hurt, the same machine can easily be converted and carry the person back to for medical care. I think that is something we believe can be deployed in short order. And so we kind of tried to come up with some baseline platform parameters. The level 1, target date 2020. Can we do it? Maybe, possibly. And 1 to 2 person, equivalent 200, 400 pound payload, and range 25 mile or better, and 60 knots cruise speed, and a little bit lower capability. 3 minutes, mainly concerned about, we can't do the mission the helicopter does. I'm not talking about replacement, I'm talking about complementing each other on all kinds of platform capability. And of course, the electric, maybe hybrid, plug-in, semi-autonomous, minimum control from the pilot operation. Level 2, like to up the ante, 2022, we can take the 3 to 4 people capability, 600 to 800 pound, and 30-mile round trip, 80 knots, a little bit longer in loiter capability. You notice I put on VSTOL as well, because sometimes it depends on the design. If a running takeoff can increase the payload by another 100 pound, that may be fine. So all depends on the design, whether we need to, but at the target area, got to be a VTOL mission operations. And you can read about the features. I won't go through every one of them, but we'd like to have an optional capability that you can land on the water. Learning from the Houston Harvey experience, if this thing can come in with a little float, it doesn't have to hover. I was watching the Seahawk dropping down the crane and hovering over there and pick up some people. That's challenging, actually to some degree, dangerous operation. Many of you know better than I do. But if we can have a little transformative vertical vehicle with a little float and coming in and land, and the guy can swing over and get it in there and come back. I think that's a lot easier and a lot safer operation. So, but I think the data link is important. 4G, 5G data link, and plus backup navigation capability. V2V connectivity you have to, because in disaster area you have to have theater command knowing where everything is, including drones and our platform and so on. So, and this is the example. We have talked about the roadmap worksheet. Just show you some of the color ones, means that we have been working on it and changing the updates and so on. And acceptance and technology. I think acceptance, we don't worry too much. If we had the capability, it will be accepted. I'm pretty confident of that. And of course, we have to work through the regulatory approval and so on, but for special application, not necessary for day-to-day taxi operation. And of course, technology is always a challenge. In many areas, we have to work on. And the more technology stuff. Over here is the example of what we've been talking about, that for each task in the previous worksheet. Oops, which one? Okay, whatever. Oh, this way. But I'm not going to go through all this. However, there will be a quiz at the reception. Yeah. Okay. So just show you guys that those have been worked on, and this will be available on the website as well. So feel free to give us input, advice, and operation. Now, here's some of the things. Due to the disaster, we spent a lot more time talking about the search and rescue and disaster relief. And in this case, it's a local operation. We can have different kinds of platform go in, including the fire situation, California wildfire. And in Puerto Rico, it's a little bit different challenge. We have a longer distance, and we don't have the platform. We probably don't necessarily have the device available. So a hybrid airship could deploy the whole bunch of our little device and complement with the telecommunication and infrastructure, drones to survey disaster areas, figure out what's happening, who's where, who need help, when, and then our platform can go do the last 5 mile deployment.
for 10-mile deployment. Take that idea further, one step further, global. That's a Boeing concept of the wind and ground effect machine. It's a huge, giant. With that kind of ship, we can deploy anywhere around the coastline within 24 hours. Maybe someday it will happen, but the regional deployment is already at hand. I mean, we have the capability, or soon we'll have the capability. And you say, okay, that's all good, but how do we get enough of our platform when we need it, where we need it? So I'm going to propose an idea here. I call it shared unit. If we can have Uber, other services, or private ownership who has some of those devices, and we signed up, registered, say, I volunteer my devices for, say, 3 days worth of use in case you need. And we do that globally, not just in the United States, globally. When somewhere, let's say Houston ran into some problem, or California has an earthquake that's pretty bad. In the neighborhood area, the theater command has, contacted us, say, hey, can I activate your device? I said, sure, I'll be glad to. Key in a security code, you have it. You take over, has a unified control command. Now we have devices on demand for disaster relief whenever we need it, wherever needed. So, all that said, all that work, disaster relief or search and rescue is very, very hard work. So, this is what we like to have moving forward. When we deploy, we can have a swimming pool and you can do a little R&R. So with that, I'll give it back to you.